Okay, good morning everyone. So today's agenda is to essentially finish the conversation on joins. So you guys can go working on lab 3. So we're going to do a little review of the joins concept, specifically talking about inner and outer joins. And then we'll start talking about self-equi joins, something you have to use in lab 3 question 1. And then we'll talk about join views, which we are not going to use in lab 3, but the whole concept is nice to know. And then we have the new join syntax that we will cover, which you can potentially use in the lab assignment, and then we'll go through the lab 3 questions and we'll be done for today. And of course, if you have any questions as a follow-up, I'll be happy to address those as we go along. So last time we started talking about joins, and we said the following. So I wanted to go to the website and bring out this Excel sheet that I created for you all last time. And you might remember this, right? So doing joins means you are trying to create a connection between two tables using references. As an example, we have an employee table and a department table. Department number is the primary key in the department table. Employee number is the primary key in the employee table. Employee table also has a department number as a foreign key. So we refer to the department number, and then we can go out and get the information from the department table. So if Bob is in department 2, meaning engineering, then we can print that information in the final report. So the point of creating separate tables and this primary key and foreign key relationship is to create the entity relationships. Now, when we end up pulling data from multiple tables, we have to do what is called a Cartesian product. So in the last lecture that was explained. Cartesian product is basically multiplying the two sets, as you can see here. So, we basically took every record from the employee table and we represented it with a row of the department table. And then we did that again for the second row. Now, when a query like this is written, we do end up writing a join condition, which enables us to choose only specific rows where the employee where the department numbers in the two match, and the rest of the rows are rejected. That is a join condition. So then the result ends up being something like this, where you have basically a set of rows that qualify from, we have set of rows that qualify the join condition. It was also reflected that this kind of a join is called an inner join. Now there are times when the value in the primary key might be a miss, meaning it might be a null, or there might be a situation where the foreign key value might be a miss, meaning it's null. So like for example, in this example, Harry is not assigned a department number. So if we want to do a report in which we can pull out all the data, including the null values, then we use the outer join concept. So the outer join concept is best demonstrated with sorry, one moment please guys, I'm just trying to get the file open here so we can talk through it. Sometimes the font size is too large. So when I'm dealing with missing values, right, I can go in and provide, I can use a plus operator on either side. So I can use a plus operator on both sides or one side to fetch the null values. So what we are basically saying is that if we end up writing a condition like this, where we are trying to bring out rows. So if Harry is not assigned to a department, then that's what the value will end up being. Now the best way to capture the outcome of this, of understanding outer joins with this specific example shows or plays very well if you please go and watch the video from last time, which is now posted on the website. So if we go back and look at the concept of outer joins, especially reviewing the slides really quick. I mean, this particular slide deck, is going to provide that information. So I just want to bring up two slides. One on that shows the query of the Equi-Joins, and another that talks about the how an outer join works. Something like this. So there are several restrictions on outer join. There are several restrictions on outer joins that you need to know about, and there are about 5 or 6 slides that follow that talk about it. So we also have the concept of a full outer join, and what we do in a full outer join is we have the exact same query, but we use the plus sign on a different side, as you can see. So here we've got the plus sign on the right side. Here we've got the plus sign on the left side. And so what we basically end up doing is bringing up all the rows where the inner join condition is met. And then we also bring rows where the corresponding values in outer joins might be null. So our next topic, so that was the review. Our next topic is on self-equi joins. So if you're trying to set up a hierarchy of some sort with if you're trying to set up a hierarchy of some sort with within the columns of the same table, then using self-Equi-Join helps a lot. So now the question is, what is a self-Equi-Join and how it works? So let's spend a couple of minutes on that topic. So if you look at the employee table, we've got employee number and we've got manager. And manager employee ID is being used to represent the manager. So essentially, Smith employee ID 7567 is a manager of Ford and Martin. So what we have basically done is set up MGR like a foreign key to the employee number call. So rather than create two separate tables, to represent a primary and a foreign key, we are establishing that notion of primary and foreign key within the same table. So if we look at the definition of the employee table, you'll find that the MGR column references employee number. So in effect, if I try to insert a value in the MGR column that does not exist in the employee number, I should get a error when I try to insert a record. Does that make sense, everyone? So when we talk about self-referencing columns, that enables joins it enables a join within a table. Am I making sense? Are people still out there, awake and alive? Okay, great. Thank you. So that brings up the notion of self-Equi-Join. So it's used with one row of a table to relate to another row in the same table using an equality operator. So in the employee table, the MGR column and the employee number column are being linked to figure out who's the manager. Who's the manager of which employee? So that's what we try and get here is we select, when we try to do this join, we are trying to do a join between the same table. So I've got employee table that I'm selecting from twice. So I make one copy of the employee table for representing a worker and another employee table that is representing the manager. And then I'm doing a join where I look at worker.mgr is equal to mgr.employee number. So that creates a Equi-Join with the same table. You're basically trying to make two copies. We're trying to make two copies of the same table and use it in the join. That is correct, Mustafa. Well, again, think about so in regards to um, Cartesian product, you can just select. So let me go back to the previous slide to address your question, Mustafa. So what I'm trying to do is print the information about the manager. So if I want to print the name of the manager or their hire date, then I have to do a join between the MGR, the first row and the second row. You understand? So that kind of join is only possible with doing an Equi-Join. So the reason we want to bother with Equi-Joins is because we want to fetch information of the manager from the employee table. So we are using the reference of 7567, and when we equate it with the employee number using two tables, that's where we basically get the concept of a Equi-Join between two tables. Here we are pretending that we have two tables, but we are really just doing an Equi-Join between the table itself. So, okay. So, okay. So self-Equi-Join and Equi-Joins are identical. It's just that how they are it's just how they are referenced is different. In this case, we are using the copy of the same table twice. So okay. So the next thing is self-outer Equi-Join. So if you try to look up employee that does not have a manager assigned, or a new manager that doesn't yet have employees, so then for those situations we can work with self-outer Equi-Join. So if the MGR column is null for whatever reason, then that basically means an employee doesn't have an assigned manager. So depending on which side of the expressions we put the plus operator, we can define the self-Equi outer join. We also have the concept of a self-non-Equi join, which is probably not useful, but for any functional reason. But if we end up using a non-equality operator in the join condition, then that would be a non-Equi-Join, especially when we are dealing with the same copy of the table twice in a join condition. If you are trying to join more than two tables, like 3 or 4, you just have to keep in mind that you have to provide a join condition for each set of 2 tables. So if I'm joining 3 tables, I'm going to have 2 join conditions. Whether it be an outer, inner, or a self-Equi join, the point is that 2 join conditions must be specified for the query to be functional. Otherwise it will generate syntax error. I'm going to talk about self-Equi join usage in the lab 3 questions. So I'll go over that in a moment. For now, we'll talk about the new Oracle 9i syntax. So new join syntax uses words like this. So if I'm trying to do an inner join rather than just use an equality operator like I was showing, I can use the word inner join and to join basically the two tables. And if we have to specify the column, then we can specify the on keyword instead of using we don't use commas between tables, and we don't use the old syntax. We just use the on keyword. So if we have column names that are identical between tables that we are doing a join on, then we can simply use the using keyword. So we can say using, using just the column name. If the column name is especially the same. If the column name is not the same, then we use the condition with different column names. So if department number is in the select list and the join condition, if you have department number in the select list and also in the join condition, meaning you're using the department, you really cannot use an alias. You have to, like in this case, I should have said using department number, like you see below, like that. This particular query will generate an error. Why? Because I'm using an alias. The second query will also generate an error because I'm using column on table. So just keep in mind as you're writing your queries. So if I'm doing a join on a table, and if I want to select two columns to do a join on, then I can specify those two conditions like this. Yes, we use column names only. We cannot use table names or aliases. We cannot use aliases like you see here, or we cannot use the alias name for the table to specify a column. I should simply just say department number, and then like if I get rid of this part, I'll be okay. So if I'm joining on more than one column, then if the column names are not the same, I can use these separate conditions, right? Or I can use the using keyword and just specify the column names. So the new syntax has keywords for joins. We have left, right, and full outer join. Instead of using the plus operator in the old syntax. So left specifies the results generated using all the rows from table 1, and null is generated for those rows in table 1 that do not have corresponding rows in table 2. Basically the definition of a outer join. Right outer join is the opposite. It specifies the results generated using all the rows in table 2 and null values for those that are not in table 2, that do not have corresponding rows in table 1. Full outer join will bring everything. Results of the inner join, left outer join, and right outer join. And we use the word outer, which specifies the results to be generated for the outer join. Of course, we have talked about what an outer join should look like. So the on and using keywords are common. There's also a union keyword. So you can do a full outer join without having to use the union keyword. So the next thing we want to look at is the concept of a join view. So these are views where you create when you are trying to take a query and make that repeatable. So view is like a table that is created from a query. When a view is created from a query, then I would usually create a view when there is a very complex query involving several tables and several columns requiring different kinds of formatting. And if I'm trying to make my select statement usage rather simple, I can take a view and take the results associated with that view, save those in the data dictionary, and then treat that as a table. We cannot do any DML statements on a view. On like normal view, but if we have a join view, we can insert, update, and delete data. So what is a join view? Join view refers to a statement created which uses a primary key and a foreign key relationship. So if I end up writing my select statement for creating a view, it must have a join condition. So the join condition on the left side is the one for representing the foreign key that is then linking to the primary key of the other table. So in this query, every row has a unique department number. In the department table. And in the employee table that we are selecting from, every row has a unique employee number. So that makes the employee table a key preserved table. So before I rush too fast into that direction, let's talk about what a view is. So I'm using the create view clause here, and what I'm doing is specifying a statement, a select statement, a select statement that we are already familiar with. By creating a view, I have now created essentially a temporary table that I can go back and refer to and select specific columns that I've defined here. So I've got the rows that will be selected as a result of this query. So let's say I get six rows. Then my view has 6 rows. That is not to say that the view has created a separate table and we have copied those 6 rows from the underlying tables into the view. That's not the case. This view is processed and kept in the data dictionary. If and when I go and select from the employee v underscore employee underscore department view, then the query will get executed on the fly and bring the results out. Does everyone understand how a simple view works? Any questions on what a view is and how it's created? Of course, the key preserved view or the key preserved table is something that we create for this kind of a view where we have the primary key and foreign key relationship set up with a join condition. So with a key preserved table, I'm basically maintaining an index of all the employee numbers and row IDs. So when I'm doing joins, my joins operate a lot faster. So this is how I can select data from that view. So the point of a view is it reduces typing and it enables faster query processing, or at least faster query writing, I should say. Query processing is another question. So key preserved table is a property of a table inside the join view. So preserving the keys means that the row IDs, the row ID and the primary key values do not change. So if I go back to this join view, the employee number and the row ID associated with the employee table, those are those the values. Like if employee number 1, 2, 3, 4 has row ID 1, that value is not going to change. The row ID will remain the same, and when the row ID and the primary key value remain identical or remain the same, then the table is set to be a key preserved table. And the idea of the key preserved table is that you can index these values. So when you're doing join processing, you can actually, when you're doing join processing, you can actually, you know, the join processing can be a lot faster because we know the keys. It is not necessary for the key column of the table to be in the select list. So if I'm using employee number as my primary key, I don't have to select employee number column for in the select list of, for the key preserved table to actually work or function. That's what the second bullet point is trying to say. So join view is subtable. It's a temporary table. If you say a subtable, meaning it has less number of columns than its underlying tables, then yes. If that's what you mean by a subtable, then yes, that statement would be accurate. So inserting a value into the key preserved table. So if I take insert into a table like this, as you can see, as long as I'm not inserting values that are prohibitive, I think I'll be okay. So please look at the first insert. In the first insert, I'm putting in employee number, employee name, and hire date. So that is just touching the employee table. So the insert will be just fine. If I'm trying to insert a value into the department, like I insert 20, right? So I've got employee number, employee name, hire date, and department name or department number. And if I try to insert, sorry, one second guys, this one has an error. So if I say, this should say department number. So if I try and insert department number in into this view, then I'm going to get an error. I should not try to insert values which requires a reference of the constraints that we have created in the underlying tables. We cannot insert values into a join view with the check option. So check option is basically saying that let's make sure that the primary key and foreign key values are, well, one is that we of course match the join condition, but when we add the check option, what we are doing is ensuring that if we do an insert of the department number in the employee table, that it exists in the department table. So if I try to insert, say, department number 150, which does not exist in the department table, then with check option that insert will fail. So we can perform a delete on a view which will delete the row in the underlying table if and only if there is one key preserved table in the join view. Like we do in our example. If we end up joining 3 tables and each one has, the primary key, then in that join view we'll end up with 2 key preserved tables. If we are updating a column in the employee table, we can do an update because our employee table is the one that is the key preserved. But again, if the with check option is turned on, then updates cannot be performed. So like in this case, we are changing the name of the employee by setting up a new name. We can definitely perform this update. But if we try to do this with check option, it will fail. We have several data dictionary views. We have user updatable columns that allow you to see which columns can be changed or not when we are creating join views. That's kind of the show of the updatable columns view in the data dictionary. So I have another slide here that I think is very interesting, which basically helps you contrast the old syntax and the new syntax. So if I was you, I would take time and go through this deck of about 10 slides that shows the usage of the old and the new syntax. So if you're just creating a Cartesian product, then we would use cross join as a keyword, where we are not specifying any join condition. If we are doing equality operator, we are using an equality operator that is also called natural join. So if I, like on the left side, you see that we have we are doing a join on location ID and country. If I just say natural join, I don't even have to specify the column names using on or using. Natural join assumes every matching column will be added in the join condition. So next is usage of the using keyword. Because the column name is the same, using keyword can be used for the column value. So, if the column names are not the same, then we use the on keyword. If we have more than one column we are doing a join on, then we can use the on keyword with specific conditions. In fact, if the column names are not the same, then the new syntax becomes a little bit lengthier than the old syntax. These slides are on my website. We then have left outer join and the right outer join. And the full outer join, which is generally a union between left and right. So I think this particular slide deck you'll find most useful because it helps you contrast the old and the new syntax, and those slides are available right here. So I think you are now ready for assignment 3. So assignment 3 has 5 problems. So what I'm going to do is just talk through each example or each question with the hopes that it's going to provide you with some guidance on what you need to do with this lab. So question number 1 says write a query to display employee number, name, hire date. So those 3 columns can come from the employee table. But then this one is a interesting one. When I say print the manager's name. So you see now what you have to do is a self-equi join. So you can say that we're going to select employee number, employee name, and hire date, and manager's name. And all this stuff will be from the employee table. So I'm going to select from the employee table twice, pretending first time I do a select is for employees and the second one is for manager. And then I write a condition. And my condition would be to match the manager's ID with the employee number. Right? And then I want to get all managers names who starts with the letter K, M, or S. So I can say and m dot e name is equal to to just kind of give you guys a start on this, right? So now you have to do K, M, or S, and I'm going to leave that challenge for you guys. Okay? Any questions on this? Or did you guys maybe already have the solution to this? So, quite likely, right? When to use like versus equality. Equality is an absolute. Like is a pattern matching idea. The next question says, create a query that will display the employee name, department number, department name, and all the employees that work in the same department as a given employee. So given employee can be a one you choose. You can just say employee ID 1234 or employee name equals, Alan. So in this query, because you're bringing in employee name and then department information, it will require doing a join, an inner join between employee and department table. So the query is actually quite simple. You can do it for every employee in the company, or you can do it for one employee. Either way, I will accept the query. If there are any questions, kindly let me know. The third question is write a query to display department name and location of all employees who are clerks. So that's a simple join condition between employee and department table, and after the join condition is specified, adding an additional condition to find if their job is clerk. So question 2 and 3 are on inner joins. Question 4 and 5 are on outer joins, and this is a deliberate attempt to have you guys try out left and right outer joins. For number 4, all you have to do is write an insert statement for the department table. Write an insert statement for the department table. So the thing to do is to because department table is a new one, right? So the one that you just added. So that will obviously not have any employees. So you're trying to write a query to display all employees in department 20, which is basically going to say, well, we have got a couple or 3 employees in department 20, and we will have no employees in department 50. So this is a question of outer join. The last question, I actually do provide you with a little bit of help because I'm asking you to insert a new row in the employee table, but I'm asking for the department number to be null. you see when department number is null, when department number is null, then the view is, excuse me, because it's a foreign key, it's kind of hard to do that. So what I did was I wrote a query for you all that that you can use in this help script. So this help script is like the one you ran earlier, but it creates a new table called employee 2. And what I did was, in this table, I have turned off the idea of the primary key. Now I do have I've turned off the idea of the foreign key. So I'm able to insert, department values that are basically null. So just to give you guys an idea here, you know how you see 10, 30 and so on, but as you look at some of these insert statements, you're going to see null values towards the end. So I've got several employees, Scott, Adam, and Miller, that all have null values. So you run the script, and then you can work on this query to show all employees in all the departments. So that would be a full outer join. Okay. So that's everything in assignment 3. And I did change the due date for assignment 3 to 5/10, so you guys can, have a tad bit of extra time to work on this, because join is one topic that you have to practice and understand really well. And in the real world, they ask you a lot about this. Okay. Any questions from anybody? So, okay guys, that's everything for today. I'm not on campus today holding office hours. I hold office hours on Monday and Wednesday, folks, from 1 to 3 p.m. All right? All right, folks, have a wonderful day, and I'll talk to you next time, same place. Take care, everyone.